One of the risks of buying cheap crap from China is that sometimes it really is crap. Kind of like this USB power bar hub thing that I pulled out of my last mailbag. But gives us a chance to just try and fix it, I guess. So, just as a recap, using its wall wart to power it, 5.2 volts. No, well, this isn't going to show us current anyway because I'm not. It's not got any load plugged into it. It's just being used as a voltmeter right now. But I got a bunch of these little guys in here which draw shy of 100 milliamps. Got my 1 amp load there, and just because I've got an extra port, I've plugged in another LED module. So let's see what happens when I start turning these things on. There's the first one. It draws it down to 4.5 volts. Second one, third one. These are just little LEDs. Fourth one, the camera's kind of swamping that out, but also it's getting dimmer, down to 3.8, and all I got on is a handful of LEDs, not even the load. Let's turn these LEDs off. If I turn the load on, boof. And actually it's just barely enough to, oh, actually, it's not even tickling that LED right now. Nothing. So there's the symptom. Question is now, is it the power bar itself? Is it the crappy wall wart that came with it? Is it the cable? Is it a combination of effects? Well, first of all, let's use just that and the charger doctor. Flip that over, and so 5.47 volts. Right now I'll plug one of these LED modules in, and it's already pulled it down to 4.9 volts. That's not really performance. This LED module's got a couple more on it. 4.7 volts, drawing 1.1 or 120 milliamps or so, give or take. So this thing has crap regulation on it. So I'm not going to trust it, which means I need to find another source of power for this thing. Now then, is this lead any good? Well, let's just see what the series resistance of it is. Okay, I'm in low ohm setting right now, which is tops out at 50 ohms. I'll just put a short on those. Go into the menu, set it to relative. So right now that's showing exactly 0, which cancels out the resistance of the leads, which is about 0.13 of an ohm. Then I will measure the resistance end to end on this guy. So 0.375 ohms on the negative, and probably pretty similar on the positive. Get in there. So 0.41 ohms on the positive. So 4, 5, 6, 7, 3/4 of an ohm. Okay. Time or multiply that by Well, that power supply claimed to be able to push an amp. This is definitely a 1 amp load. So at 1 amp, that's 3/4 of a volt lost just through that cable. So that's kind of useless. So let's find a better power supply. Like this one here, which is Vivitar branded, and it says it's 1,000 milliamp power supply. So that's awkward though. Can you even see that? Okay, so that's 5.2. I'm going to put my 1 amp load on it. It's pulled itself down just a bit, but it's regulated itself back up to pretty much 5 volts, bang on. This is only claims to be 1,000 milliamps, so if I put that up to 2 amps, it's going to swamp it. But okay, so that's a reasonable power supply. Let's see what happens if I plug into there with that. And where are we here? Okay, so that's that. I'm going to turn on a couple of LEDs here. Down to 4.6 volts. And we know that isn't the power supply sagging. Let's throw one more of these LEDs in. 4.4. That's pretty much the bottom limit of the USB spec. USB spec says 4.5 to 5.5 volts, give or take, if you want to go deep into it. But for what we're doing, that's close enough. So, and we know that it's not the power brick coming down this time. So it's going to be either that wire or inside of here. Okay. So what's the next test we can do for this thing? So I don't want to trust this for power. Okay. Let's see if I can find another power supply that fits that little plug there. So one of the benefits of being a bit of a pack rat is that you tend to accumulate useful things like Woolworths and power supplies. So let's see what we can find in the 5-volt box. 2,000 milliamps, wrong plug. I think I'll actually just dig through here until I find wrong plug. Wrong plug. Oh, that looks like the right one. What's that got to say with it? 2.5 amps at 5 volts. That'll do nicely. Okay, is this? Yeah, it is. Cool. Okay, let's go with that. This one, really thick cable. Like, this is like AC power cord. There's my soldering iron. It's power cord here. I mean, that's serious. We're not going to get any losses in that at 5 volts. So plug that. Oh, actually, hang on here. Plug that in over there. Plug that in there. Get this up out of the way. And let's turn on a bunch of these. Let's see what that has to say for itself. That's more like it. Still rock solid 5 volts. Okay, so the power bar thing itself is reasonably decent. Let's put the 1 amp load on and see what happens. 4.85 volts. That's still well within the spec. Did we dare flip it up to 2 amps? Okay, I'll flip it. There's a 2 amp load on there. So 2 amps plus 400 milliamps worth of LEDs, roughly. And we're still at 4.75, well within the USB spec. That's what I wanted to see. So that's 2 problems solved. This crappy little power brick, which I'll take a look at in a minute, and the crappy little wire. I don't want to draw the power through this crappy little wire. One thing somebody suggested to me, though, is that there may be bad isolation between this feed and this one. That was, somebody said that in the comments of the other video. So I'm just going to quickly set up here to test that. Okay, so what I've got is DC power coming in there. I've got a USB female plugged into that, and the power leads clipped onto my voltmeter, and there's 5 volts coming out there. There shouldn't be. You don't want to backfeed 5 volts or any voltage from this, from an external power supply through the USB back to your computer. So that's something to keep in mind. Don't be using this with the external power and the computer at the same time. That's not going to be an issue for me because I didn't buy this to use it as an actual hub. I've got an actual brand name hub that I trust over here that I'm going to use as an actual hub. This I literally just wanted as a USB power bar for charging and stuff. So, next thing I'm going to do is crack that guy open and take a peek in, but also remove this USB cable because I don't want it. I don't want this to accidentally be used as a USB hub. Yes, it's wasteful. The thing wasn't all that expensive, and this is not why I bought it anyway. Okay, spudging time. There's no screw holes or anything. This thing looks like it's just kind of clipped together. I'm basically just using the big spudger to get in through the through the narrow little slot and open it up enough so that I can get the less flexible spudgers in. And let them do the brute work. Pop, there it is. Okay. So let's a little bit more zoomage here. So we have a circuit board. Bunch of switches, bunch of LEDs, bunch of USB connections. This cable here, which, as I already mentioned, is not long for this world, doesn't need to be there. Oh, okay. So the power jack actually has 3 pins, but it's a 2-conductor coaxial. So one of those pins is going to be a switch, basically. Can we see the back of it there? Sort of. It's supposed to have a switching action inside it. Obviously it doesn't, or if it does, it's horrible. The other thing that's really obvious is they didn't do a single bit of flux cleaning here. Do I have any alcohol in my... I do. This is just really cosmetic. It's not a big hairy deal, but it's a nice thing to do. I'll spend some more time on that off camera. You don't need to watch me cleaning. And if you do need to watch me cleaning, I actually have a video called Cleaning, or I'm cleaning my model railroad. But it's got like 12 views. I'm not really expecting anybody to watch that. Okay. So we got a couple little blobs here, U1 and something else. Can't read it because of the blob. Zoom in a bit tighter here. Okay. The LED leads are not really trimmed off all that close. So potentially they could, hello focus, short down to the other tracks, or at least they could if there wasn't solder mask on there. Still, it doesn't hurt to do a little bit of that just for good measure. Nobody likes short circuits in their products. Although obviously the cheapest Chinese factory where this was made doesn't give a damn about it. Okay, that's that cleaned up. There is, I notice, a hole in the case right there that looks like it should have a power LED on it, but it doesn't. Nope. Okay, well that does. Oh, there's where it would go if it did have one. Might add one. Don't want to. Don't care that much. Okay. So the power tracks. No, they're pretty skinny actually. I guess the power tracks go to the switches, don't they? And they got great big. Where am I here? Something to point with. Yeah, I mean they got great big pads to solder onto, and they go up to these skinny little tracks. So I'm not super jazzed about that. But we saw that it would draw the full amperage, the full 2 amps down at the far end without sagging the thing too horrendously. I think there was some resistance in there, but I don't know. I guess I can live with that for what it is. Okay, that's that guy. Yeah, those blobs are just the standard USB hub chips. I'm gonna guess one of them does 3 and one of them does 4 ports, something like that. Nothing too crazy or out of this world in there. Let's see what's in this piece of junk. And not expecting anything super duper. Oh, they did put a little bit of effort into separation between the high voltage and low voltage sides of the board. That's kind of nice. Surprising. Ooh. But they also save money on wire cutting too. Check those leads. Holy crap. What part is that on? Looks like it's just on that Zener diode there. Regardless, even though I'm not going to use this for anything critical ever, the potential for short circuits in there is just horrendous. Yeah, that's better. I've seen worse. And what's going on in here? Just a single transistor switching power supply by the looks of it. Let's see, focus you. What do you got here? A diode right off the line. Capacitor, the transistor over there. Zener diode. What's that other diode under there? Another little diode down in there beside that resistor. A couple of caps. What's the voltage on these caps? Okay, that one's 2.2 microfarads, 400 volts, which makes sense because it's like literally the second thing that the full voltage sees. What's this thing rated for input voltage? 100 to 240 volts in 5060. Okay, so anything really, universal. So 250 volts, peaks to be up in the above 300. So that's not an unreasonable number. It's, diode's not too bad size. That 22 microfarad capacitor over there is 35 volts. No, 25 volts. That little ceramic capacitor. Hey, there's no feedback. That's probably a big part of why it's got no regulation. There's no feedback. See this footprint here, which has 4 holes surrounding it? That screams opto-isolator, and you notice that there it is missing. So what's on the secondary side over here? We got a smoothing capacitor, resistor, and the LED, and a singular little diode. And that's all that's on the secondary side. It just says D3, so it's a standard, it's a rectifier diode, a small, tiny little rectifier diode, but a diode nonetheless. So that's this little thing. No wonder it's useless. Suppose I could use it for super duper low loads. What was it, only a couple hundred milliamps before it lost or started sagging below the standard? This thing, snap her back together, really. It's not at all complicated. Drop that in there. Snappity snap. Done. Alright. Thanks for watching. I'll talk to you next week.